We're now going to continue with creating a surface forcing file for the ROMS model. And we're going to tackle this, the qscatt winds, which are satellite winds, which in the previous example, there was an error. Now the error was due to the fact that one of the utility was not properly installed on the master node. However, it is properly installed on the qscatt machine, which is the first machine where you log in. So we're going to actually run MATLAB from this machine. I'm going to go in the ROMs NC files, start up MATLAB here, and then in the edit here also I'm going to go in the NC files and open this main forcing file that we were working with. Okay, so I'm going to go further down to where the inputs are. Okay, and first let me execute this first part of code here in MATLAB, which is the definition of the grid and so forth. And then I'm going to skip forward and go to the time-dependent forcing. And we were working with, say, year 2001, so we can, produce this particular time period here. So I can go in MATLAB and run that. And the next thing is I was going to create the name of the forcing file and assign this myDate array. And then back into the edit window. Here now I have a choice of which forcing product to extract. The one that we worked previously was the NSEP reanalysis, from which worked fine. And then we encountered an error when we were working with the qscatt winds. Okay, so now you can see that on this machine this utility works. So if I go here and I execute this qscatt, it's going to actually start extracting the qscatt winds. And now this is a long process because these are actually 4 times daily winds. So it has to extract every day in this. These are particular file called HDF files. Has to extract these and then take the monthly averages and so forth. And this is a large data set because this is I think the qscatt grid is about 25 kilometer resolution. So it's actually in this case more resolved than the North Pacific grid that we're running. So it's going to take some time, but just to show you, I'm going to stop this because I don't want to wait, but just to show you that in principle, for example, suppose I wanted just to extract one particular day of 2001, so I can say date num, say 2001, say January 15, okay, this would be like a one particular day. So if I did that, it would extract just one day. Okay, so it's already done basically. And if I do fork D, what I have here now is, oops, sorry, it extracted the entire month. That's interesting. So what we have here is that's very strange. Oh, I'm sorry, I made a mistake here. And the mistake is that I just used fork type, which is not the fork type that I want is daily, okay? And it's myDate where I have to put the date. So here I'm going to replace it with date num of 2001, comma 1, comma 15, okay? And I'm going to just take the daily value, so I'm not going to do a monthly average. So if I do this, this should actually work. And in fact here is extracting a particular file, and fork D now has only one value, which I can plot by just doing pcolor fork D dot lon, comma fork D dot lat, comma fork D dot sustr. And I'm going to create a new figure here. That's right. So that's the product. Then I'm going to do shading flat. Okay, and then I'm going to say hold on, world coast. So in this case, what you see is that the qscatt winds, it's not defined everywhere, the daily values, and that's because these are instantaneous, pictures, and not every day you have a full coverage. You see, there may be some noise and stuff. So in practice, extracting this data set is not probably the best thing to do if you want to force ROMs. But what you can do is extract a mixture, a blend data set that uses these satellite winds together with the NSEP reanalysis to come up with a more consistent estimate of the wind field. And in fact, such a data set exists, and it's accessible to you through this NSEP qscatt blend. It's right here, which is work done by Millif et al. In Boulder. And so, for example, if I now use this particular function to extract the winds, oops, if I can just operate the mouse correctly today while I'm sick, I can go and edit here. MATLAB. So this would be a better way to extract this product. And so this is extracting now January 15 and so forth. It's going to keep on going. Once again, it takes some time even for this blended product because this is also daily averages. So for example, I'm going to stop this and just show you that it's working. I'm just again going to extract only the day that we were looking before, which was date num. It was 2001. It was the January 15. Okay, and so I'm just going to extract one value. And fork type again. Since I was doing the monthly, I'm going to go back to the daily values, just to show you the comparison of that. And so I'm going to call this array 40. Okay, that's fine. And so it's going to take a little bit of time here. Right now, what it's doing with this building map, this is doing an objective mapping to fill some of the coastal values. And it could take some time. And so it's done. Fork D, so now we have it, and we can plot this as well. P-color, where was we use the P-color statement somewhere. Oh, there it is. Okay, so we can plot this now. We can do shading. Actually, in this case, for this fork D, I think we have a mask, so what we want to, it's the land mask, so we're going to use that to show only the ocean values. Okay, very good. And then we're going to do shading flat, color bar. And then we're going to say, hold on, world coast. So this is now this blend product, and we can compare this to the previous one, which was the unfiltered product, which is here. And we can put it on the same axis, so that let's do color bar. Figure 1, color bar. Okay, and you can see that there is resemblance between the two. Like there's this big zone here of stronger winds here, but you can see that all this crappy values that are in this unfiltered qscatt satellite product have been kind of corrected using the NSEP reanalysis. So now you have a wind product that is more uniform and, if you like, better tested. And you can read the Millif et al. Paper, which is the reference. I think it's contained here, and find more about it. For this product, we have currently on the cluster ready for you to extract from 2008. So that's good. So in other words, I wouldn't recommend you extracting the qscatt winds, rough directly like that, but use further this qscatt NSEP blend, which is probably better. Okay, so this concludes now this surface wind forcing fields, and so we've seen that we can run either the NSEP or the NSEP qscatt blend, and once again, for the purpose of this example today, I want to keep working with the NSEP, so I'm just going to comment this out and save this file. Okay, this concludes the second part of the tutorial on surface wind stresses.